recommend moving on to the next one. So, now that we've kind of set the table, set the stage for an understanding of the free energy principle, one of the, I think, interesting questions to answer might be, what are the main frontiers at the moment? And hearing this from you yourself, Karl, would be super interesting. What do you think are the most critical, outstanding areas of investigation that are being pursued, and what do you think are the most exciting directions where the field is moving currently?
Right, that's a very good question. I think probably best addressed just by standing back and asking, in and of itself, what is the free energy principle? The free energy principle is just a method, and you can only apply a method. So I would read that question as, what are the exciting applications of the free energy principle? And that usually boils down to how you would specify the requisite generative models to which you apply the free energy principle. And there are all sorts of fascinating, challenging, sometimes very vexed issues, depending upon the domain in which you are trying to apply the free energy principle. So things that come to mind without really thinking about it properly are the I'll set you up so that you can come in and say what your favourite outstanding issues are. But one of the key issues in terms of application of the free energy principle is the establishment of Markov blankets, noticing that there's not just one Markov blanket. As soon as you're talking about generative models with any useful cause-effect structure, they are now equipped with Markov blankets within Markov blankets within Markov blankets. So a simple example of this would be the kind of generative models that have a hierarchical depth that you could argue gives meaning to deep learning under deep neural networks, for example, where the deepness corresponds to the hierarchical depth, but the hierarchy is just determined by the Markov blankets that allow you to separate, disambiguate, or individuate one level of organizational states from another level. So the Markov blankets of Markov blankets and their composition, I think, is a very fascinating area that speaks to all sorts of interesting challenges and interpretational issues, not least, I'm thinking here of our work with Chris Fields and the inner screen, the irreducible Markov blanket in consciousness research, right through to wandering Markov blankets that move around, that can be replaced in terms of the constituent elements, yet retain that sort of structural symmetry. Other more practical challenges or forefronts of application would include the scaling of the machinery, the basic mechanics, sometimes referred to as active inference, as these generative models become more and more expressive and get larger and larger in a well-defined sense. And I don't mean that they just have more degrees of freedom, but they have a more expressive and complex structure in the sense of their hierarchical depth or their factorial breadth. Another interesting issue, which I think has yet to be addressed, and I'd like to see addressed, would be episodic memory. At the moment we have ways of simulating, at least at a smaller scale, many aspects of sense making and decision making and planning that speak to things like artificial intelligence research on the one hand, or modeling psychopathology on the other hand, or neurorobotics on the third hand. But what we don't have, I think, at the moment is a compelling mechanics of episodic memory, that I can remember episodes in my past and have a source memory which speaks to a particular kind of metacognitive or meta-inference aspect to this self-evidencing. Maxwell, I'm exhausted. Can you think of Three
Well,
more
three
frontiers.
more. So I think there's interesting work on collective intelligence,
Yeah.
multi-agent dynamics, morphogenesis, coming out of various different labs actually. So, maybe you can comment more like on the AI side. On the biology side, I mean, there's Mike Levin's lab and people like, Santosh Manika, Franz Kupling, who are doing really, really cool work on basically modeling morphogenesis and the principles of, multicellular self-organization using active inference. I think that's a big one. Do you want to comment, maybe point folks to
When,
specific strands of work? We
yeah,
have this cool paper, a few cool papers that we published last year too on this, right? On federated inference.
right. You want just to endorse that. Yeah. So, once you've got your head around or mechanics applied to oneself, you suddenly start to think about what about two selves, and we're in the world of multi-agent simulations on the one hand, or social neuroscience on the other hand, which could be limited to dyadic interactions, which of course are very important in terms of interpersonal exchange, but particularly in terms of therapeutic dyadic interactions, right through to ensemble behavior and swarm behavior and distributed intelligence on ecosystems of interacting agents. And this is a fascinating area that, as you say, starts now to drill down in a particular way on this generalized synchrony and what enables this generalized synchrony between two active inference artifacts or processes, or even more, and how one can apply the active inference in this context to understand belief updating in this federated context, namely belief sharing, and that in turn now speaks to language. And then you ask, where does language come from? And then you start to think about other frontiers that you implicitly brought to the table, which is the application of the free energy principle at different timescales, usually nested timescales. So normally when we start talking about active inference, we're thinking about sense making and decision making in the moment, and thinking technically about where does expected free energy get into the game, and unpacking that in terms of expected information gain and expected value. But there are other really interesting timescales where you can apply exactly the same principles to talk about active learning, learning those rules or contingencies or parameters that underwrite the functional form of our generative model, and then the very structure itself. And now, how do you select the right structure? And that leads naturally into the notion of natural selection as Bayesian model selection, and one can then read that in terms of structure learning over slower timescales, and how we come to grow or indeed shrink or reduce different models. So again, wherever you look, there's a direction of travel which could be regarded as a particular frontier, depending upon how you want to apply the free energy, whether it's right down to the level of mitochondria, as some of Mike Levin's colleagues are currently contended with, or right up to the level of societal interactions and message passing of the kind that, that indeed you and your colleagues have done in the work of people like Connor Hines.
Awesome. So that was one.